Ever pondered why matter has mass? The answer lies in an elusive particle, often called the God particle. This elusive entity, formerly known as the Higgs boson, has been the subject of intense scientific scrutiny since its discovery in 2012 at the Large Hadron Collider in CERN, Switzerland. Why such an enigmatic name, you ask? Well, it's partly due to the particle's role in granting mass to other particles, a role so pivotal that it's been likened to a divine function. It's also due to the fact that the particle was notoriously hard to find, leading some to question its existence altogether. In essence, the Higgs boson completes the standard model of particle physics, our best description of the subatomic world. So let's delve deeper into this fascinating world of subatomic particles. To understand the God particle, we first need a grasp on the standard model of particle physics. Now, the standard model isn't your everyday model. It's essentially a rule book for how the smallest bits of the universe interact. These bits, or particles, are the building blocks of matter and the forces that govern them. The model is divided into two main categories, fermions and bosons. Fermions are the matter particles and include quarks and leptons. Quarks are the elements of protons and neutrons, the building blocks of an atom's nucleus. Leptons, on the other hand, include electrons and neutrinos. Then we have bosons, the force particles. They carry four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. The most famous boson is the photon, which carries the electromagnetic force, responsible for light and electricity. The strong nuclear force, carried by gluons, holds quarks together in protons and neutrons. The weak nuclear force, carried by W and Z bosons, is responsible for radioactive decay. Gravity, the most familiar force, is theoretically carried by a particle known as the graviton, but it has not yet been detected. The standard model, as complex as it is, has been incredibly successful in explaining the majority of experimental results and precisely predicting a wide variety of phenomena. However, it does have its limitations. It doesn't incorporate gravity, and it doesn't explain dark matter or dark energy, the mysterious substances that make up the majority of the universe. In this complex dance of particles and forces, there was a gap. A piece of the puzzle was missing. This missing piece was anticipated by the standard model, but had eluded detection for years. This elusive particle was none other than the Higgs boson, often referred to as the God particle. And in this intricate model, there was one missing piece, the Higgs boson. Enter the Higgs field, an invisible energy field that permeates the universe. This isn't a scene from a sci-fi movie, but a cornerstone of our understanding of the cosmos. Now you might wonder, what's so special about this field? Well, it's key in giving particles their mass. Let's break it down. Imagine a universe without the Higgs field. In such a world, all particles would be massless, zipping around at the speed of light. There would be no atoms, no stars, and no us. But thanks to the Higgs field, particles slow down, acquire mass, and the universe as we know it comes into existence. So how does this work? Picture the Higgs field as a cosmic molasses. As particles move through this field, they interact with it. The stronger the interaction, the more they slow down, and the more mass they gain. It's like trying to walk through a pool of honey. The more you struggle, the slower you go, and the heavier you feel. But wait, there's more. Associated with the Higgs field is a unique particle, the Higgs boson. Named after physicist Peter Higgs, the Higgs boson is the only known elementary particle with zero spin. It's also hefty, weighing in at 125 billion electron volts. But don't let its weight fool you. The Higgs boson is incredibly elusive, popping in and out of existence in a fraction of a second. The Higgs boson is essentially a ripple in the Higgs field. It's the physical proof that the Higgs field exists. When scientists at CERN discovered the Higgs boson in 2012, it was a monumental moment, confirming our theories about how particles get their mass and how the universe is stitched together. The Higgs boson, the particle that completes the puzzle of our universe. Fascinating, isn't it? Finding the God particle was no easy task. It was a feat that required the combined efforts of thousands of scientists, groundbreaking technology, and an undying curiosity about the universe's inner workings. The stage for this epic discovery was set at the Large Hadron Collider, or the LHC, nestled in the heart of CERN, Switzerland. The LHC is not just any scientific instrument, it's the world's largest and most powerful particle accelerator. Picture a ring-shaped tunnel, 17 miles in circumference, buried deep underground. Here, particles were accelerated to near light speeds and smashed together, creating a flurry of new particles in the process. It was within this microscopic mayhem that scientists hoped to catch a glimpse of the elusive Higgs boson. The pursuit of the Higgs boson was akin to finding a needle in a cosmic haystack. The particle is incredibly unstable, and upon its creation, it immediately decays into other particles. This meant that scientists couldn't observe the Higgs boson directly. Instead, they had to look for the specific particles it decays into and the unique signatures they leave behind. The year was 2012, and anticipation was running high at CERN. After years of meticulous planning, rigorous experimentation, and careful data analysis, the moment of truth had finally arrived. In July, scientists announced that they had discovered a new particle consistent with the Higgs boson. It was a eureka moment that resonated around the globe. The God particle had finally been found. This monumental discovery not only proved the existence of the Higgs boson, but also validated our understanding of the universe. The Higgs boson had been the missing piece in the puzzle of the standard model of particle physics, and its discovery filled in the gaps, giving us a complete and coherent framework for understanding the fundamental particles and forces that shape our universe. The discovery of the Higgs boson was not just a triumph for the scientists at CERN, but a victory for human curiosity and our relentless quest to understand the cosmos. So, why does the Higgs boson matter? Well, imagine the universe as a cosmic stage where particles are the actors. Without mass, these actors would buzz around at light speed, not interacting with each other. It would be a chaotic performance. Enter the Higgs boson. It's like the director, slowing down the actors, giving them mass, and allowing them to interact to create a meaningful drama. The discovery of the Higgs boson completes our understanding of the standard model of particle physics. It's like finding the missing piece of a grand cosmic puzzle. It not only validates our theories, but also opens up new horizons for exploration. The Higgs boson could potentially lead to groundbreaking advancements in our quest for quantum gravity, and even pave the way for a unified theory of everything. It might help us understand dark matter, dark energy, and the very fabric of the universe itself. Indeed, the God particle holds the key to unraveling the mysteries of the cosmos. The God particle, a testament to human curiosity and our quest to understand the universe. The Higgs boson, a fundamental force-carrying particle, has been an intriguing subject of discussion throughout our journey today. Its discovery at the Large Hadron Collider in 2012 not only completed the standard model of particle physics, but also unraveled a hidden layer of our universe. This elusive particle, named after physicist Peter Higgs, is responsible for granting mass to other particles through what we know as the Higgs field. This interaction, explained by the Brout-Englert-Higgs mechanism, has undeniably revolutionized our understanding of the cosmos. And while the Higgs boson may be the only elementary particle with zero spin, its impact on science is anything but insignificant. As we continue to delve deeper into the mysteries of the universe, the God particle remains a beacon of scientific achievement and a testament to human ingenuity. Remember to like, subscribe, and share your thoughts on this mind-bending journey into the world of the God particle in the comments below.